Hey, boys and girls. I think I'm blurry. I hate being blurry. Anyway, I'm going to try to muddle through this alone. I am not good at doing monologue open streams, but I had this on the plate for a while. I wanted to get into it a little bit. There is a resource that I stumbled onto about, God, it must be like 10, 15 years ago already, when I was studying neuroscience, called the Scholarpedia. And I can show you what it looks like, and I have linked it in the description of this video. So it's a little known resource, and it started in 2008. I think they got the idea about the founding vision, according to ChatGPT, was 2005 to 2007. And they're trying to bridge the gap between traditional journals and the wiki. So every article is written by an invited expert, which is kind of cool. And it started out in 2008. They had a number of articles. I think they had like 5,000 articles. 2012 they had 1,400. 2018 article count. Okay, well, they had more than that. 1804, and then let me see, in 2024 they only had 7 new articles accepted. And it's got, if you look over here on the left, it's got astrophysics, celestial mechanics, computational neuroscience, which is what I started out with, computational intelligence, dynamical systems, physics, touch, and I don't know if they got more topics. Yeah, experimental high energy physics, nuclear physics, quantum and statistical field theory. I mean, this is quite a resource. You go to computational intelligence, I think, let me see here. Is that computational neuroscience? There's one, they have a consciousness section, which is really quite cool. And they've got, I think, let me see here. Only the ones in blue have actually been submitted. These other ones, like, let me see here if there's some big guys here. David Edelman, basically, proposed animal consciousness, and Dr. David Edelman never actually completed it. And if I'm not mistaken, let me check something here. I'll show you some real stuff. David Edelman. Let's see. Nope, that's not the one. Can't find him. Anyway, David Edelman, LinkedIn, Greater Boston, David Edelman, neuroscientist. Should have had that ready. On the third way of evolution, David B. Edelman, evolution scientist. I think he's the one. How memory is related to consciousness with David Edelman. There's a bunch of other things. But anyway, so the ones that are done are pretty cool. There's attention and consciousness. And that one is done by Christoph Koch and Natsugo Tsukaya. I'm sure I didn't pronounce that right. But it's got a pretty extensive article. And it's done by experts in the field. And this one is quite long. If you want to get into the field of neurophilosophy and consciousness, this would be the way to do it. Hang on a second here. Let's see if I. Oh boy, nobody's listening. I like that. So I kind of dropped this out. I'm hoping. I want this resource to be known because it's really important. There's just a ton of stuff here. You got basically a huge article by an absolute expert in the field on a ton of different things. So let me see what else we got here. We got consciousness, and then we have the one I love is experimental. Okay, where's brain theories? I'm trying to find brain theories here. Maybe it'll be computational intelligence, cognitive science, computational neuroscience again. And somewhere here we have brain theories. I can't quite find it. Computational, okay, cognitive neuroscience. It's really kind of it's kind of deep, and they sort of wrap around, so you got to dig around for what you want. But if you go here to brain models, there's models of consciousness, models of emotion, brain connectivity, connectome, holonomic brain theory. I'm trying to find confabulation theory. Let me see, we'll go back here, back to brain models. Let's see, was that brain theory? Brain models. Why can't I find confabulation? I know how to find it. I know a way to find it. That is in computational intelligence, confabulation theory. This one right here. Cognitive science. My goodness. I guess I'll go to my link. I linked this one in my description because I think it's wonderful. Let's see here. Okay, this is confabulation theory. It's a comprehensive, detailed explanation of the mechanisms of thought. And the idea behind this is they believe that thinking, oh my God, I didn't want to go there. Don't want to do that. I want to go back. Thinking is a phylogenetic outgrowth of movement, which is really interesting. They go ahead to sketch out the theory down here. And that means that our motor cortex basically controls all of our muscles. And that's right in the middle of the top of your brain. And it's kind of a band that would look like you had headphones on at the top of your brain. Right in front of that is your premotor area where you plan movements, where you can imagine that you are moving. And this is where the really bad idea of mirror neurons came up. That because if you're watching somebody else move, they can see you moving your premotor cortex, which means you're not really moving yet, but you're thinking about it, right? And this planning movement, they believe, was exacted phylogenetically somewhere along the line, probably in early mammals, to more like primates, to be the thinking that we do when we say, "Oh, I'm thinking about it." You know, what does that mean? Well, you're in there going through your concept space, you know, which is kind of similar to your room space, and you're thinking about one thing at a time, and you click from one thing to the next. And this whole mechanism is really interesting. It's involved the basal ganglia is at the center of your brain, and that has an action selection kind of mechanism where you can move to the next thing, and you can either move your muscles or you can move to a new thought. And I'm always fascinated with the idea because my brain does not work very well, right? I have no control over my inner thinking movement, mostly because of ADHD. But if you can train movements like a martial artist, you should also be able to train your thinking like a martial artist and come up with a kind of a clear a skill. Learning how to think is a skill. And a lot of people do it really well with logic and whatever field you're in. But anyway, it tells you that you can learn just like you're learning martial arts. You're learning these precise forms and movements. You can learn precise forms and movements in your conceptual space or in your thinking. So it's kind of a universal theory of animal cognition. And this is pretty cool here. They talk cortical patch. They talk about these little cortical columns and how they go from one thing to another, and they get into some detail. So I think if you read this article, you'll be pretty thrilled. Anyway, okay, so back to computational intelligence. Here's some neuroscience. If you want to learn what the hippocampus does, you go here. And the hippocampus has a lot of subcategories. Grid cells, okay, grid cells are, well, let's have models of the hippocampus. Okay, so that gets you into the anatomy. And who did this article? Somebody I know, I'll bet. Nope, that's Elmo. I don't know. Anyway, that gives you a good overview of that. Grid cells are the things they discovered in mice where they can actually watch a mouse thinking about going through a maze or dreaming about it at night. And that has to do with these grid cells that are laid out in the hippocampus. So you go like when you move through space, you can actually see this light up and then that light up and that, almost like you're watching the brain move through its own space. And I always have kind of a semi joke that the hippocampus developed in early rodents who needed to find their nuts. So they had cache stores of food, and they need to navigate a huge space and find thousands of nuts that they've stored, over the summer in the winter. And these grid cells allow them to do that, and that's sort of developed into something that helps us figure out what we've done today, basically. Like, it's really interesting when you think about your day yesterday, you'll find a little index seed and you'll think about something that happened probably in the morning. And you can go from your breakfast, getting out of bed, your breakfast, tripping over the cat, letting the dog out, get ready to go to work, driving to work, which is really interesting because you'll start at home and you'll actually think your way through the route. And what you're doing is you're going through these grid cells from one to another, and they can actually see this on a brain scan. And that hippocampus is, let's see, I wonder if they have a picture of the hippocampus anywhere. Probably not on this one. Let's see, and they recommend future work and then all the articles that they link. So going back, entorhinal cortex, head, direction cells, hippocampus itself. Okay, so that's your hippocampus right there. It looks like a oh God, I forgot what a hippocampus is. Anyway, it's this little curly thing that's in your basal ganglia, kind of at the center of your brain. You can sort of see where it is. And banana-shaped hippocampus. And then let's see, what do we got here? We got a diagram how it works, and then we have the little picture about the rats where they're watching them, basically move through space. And then we got some uh, interesting stuff on signals, whatever. Okay, so that's hippocampus. And let's see, entorhinal cortex. Let's go back to neuroscience. So gastropod neuroscience should be pretty interesting, and they have a whole bunch of articles here. Tritonia, gastropod reproductive behavior. Let's go look at something random that I've never seen before. Oh my God, look at that little critter. How would you like to find that crawling across your stomach? Sea slug used for research in neurobiology of learning and memory. And oh my God, is that by? No. Okay, it's Kim Blackwell and Joseph Farley. And here again, we have a tremendous amount of information and read. So if you wanted to learn about neuroscience, you could spend a year just digging into this stuff, going from one section to another. And some things bottom out at a here's one on sleep. Some things bottom out at an article, and other things you can go deeper. Neurobiology of sleep and wakefulness, which is all about how the thalamus gets these signals, and when you go to sleep, the thalamus kind of goes into this tonic mode, and it cuts out all of the stuff from your muscles and your sensory organs, except for sense of smell, and you fall asleep, and then you start operating your hippocampus to dream and integrate things with your cortex. So there's that. And now let's see here, category sleep, category neuroscience. What else was interesting there? Old-fashioned electrophysiology, computational intelligence, which goes really deep. If you want to learn graph theory, recurrent neural networks, robotics, signal analysis, it's just loaded with things. And here we have our brain theories and brain models linked again. There's a number of ways to get to it. If you try to map this out as a tree, it becomes a little confusing in your head. Anyway, but let's look at some stuff that I've never seen before. Oh, wow, touch. I don't know what touch is. Oh, that's just an article on touch. Okay. But we have astrophysics, which I have never looked at. So here is the entire astrophysics thing, which I only looked at neuroscience, but now apparently the new articles that are, there's just very few people that are paying attention to this. And a lot of these guys that signed up for articles didn't finish them. But this one, they're all in blue, and they're showing a whole bunch of completed articles. So extragalactic astronomy. Here we go. Galactic magnetic fields, Tully-Fisher relationship. If Leo, if you happen to be watching this, I'm sure you're going to love this thing. There's just a ton here. Computational celestial mechanics. So you got planetary physics. What do we got? Cosmic background explorer, COBE. That apparently is something we threw out into space. Physics and space, not my main field, but very interesting. Let me see here. We got physics. Let's take a look at physics. Oh, we only have an article on physics. Oh, wait a minute. Portal page containing, okay, astrophysics, celestial mechanics, condensed matter, dynamical systems. Now, these things, this is about chaos theory, and it's just a wonderful bit of complex physics that you could spend your life understanding and getting into. Here we have chaos, and that has a number of articles. See these guys here, like, let me see here. We got, what do we get? Okay, Pleiken attractor, Eugene M, whatever. Now, if you see, this is by Roman V. Pleiken. If you run into him, tell him to finish the damn article, because he signed up to do it and was invited on April 8th, 2008, never did it. I think these people signed up. Now we have chaos and optics, whole bunch of stuff. And I have somebody watching. I don't know who it is. Oh, Will Freeman. Oh, hi, Will. Hi, Will. Let's see, differential equations. So you got mathematical theory. And this is boundary value problem, normal forms. I'm trying to find something like Punnett function. That one's pretty short, but still, a resource. Boundary value problem. And let's see here, what else? Encyclopedia, dynamical systems, statistical mechanics is very easy, or very, very interesting. Glassy dynamics. This is really interesting. There's an intersection with biology here and how statistical mechanics kind of reduces things. It's very reductive. And there are other considerations when you get into complexity theory. I'm surprised I don't have anything on complexity theory here, but anyway, so that's it. Links are in the description. If you value education, self-education, this is really, really a great resource here. Computational neuroscience, electrophysiology. Let's go look at something here. Memory. We got 1, 2, 3, 4, 5, 6, 7, 8 articles on memory, modulation, amnesia, cognitive psychology. Let's see, conceptual short-term memory. Kind of an interesting article. CSTM, your mental buffer, your working memory. Basically when you're trying to remember a number or remember why you came into the kitchen, that sort of thing. And that all involves the hippocampus too. Yes, Ryan Murphy is joined. There's a place where one can read up on things. Yeah. Anyway, what else we got? Random article. I don't know what that is. Random article, instruction for authors, propose a new article. You can also contribute to it too. So I guess they got tools here for contributing. What links here? Printable version. Anyway, that's all I got on this. I've had this on the books here since May, I think, or earlier. And not seeing about density. What about density? What do you want to look at? Not seeing about density? I'm not sure, Ryan. Let's see, what else can we look at? I love computational neuroscience. Experimental neuroscience, spiking networks. Okay, here's how you get the brain models, which are really interesting. Models of consciousness, brain, kind of. Okay, let's see. Holonomic brain theory is something that's interesting. Let's see, what is the overview of that? Type of process that occurs in fine fibered neural webs, the process composed of patches of local field potentials. And I think down here, okay, they talk about these, like the interesting thing when you're, I'm trying to kill a fruit fly. The interesting thing when you're trying to remember something, you're trying to remember that the name of that band or the name of that actor or whatever. Your brain sort of goes through all these like fluctuations where you have peaks and you have valleys. And the harder you try to remember, the more you force yourself into one of these valleys. Well, if the information is not there, it'll feel like, oh, I should know this, but I don't. So you can't really hook your hippocampus up to your cortex and remember where it is. But then if you relax a little bit and start doing something else, the thing will flatten out a little bit. And now your brain is capable of zipping around a little and a little wider. And it's interesting that they've put monks and people that are meditating or in a spiritual state uh, in these scanners, and they tend to be flat and wide. So your whole brain is kind of like just simmering at the bottom. And then when you remember something, you'll end up driving into one of these valleys. And you'll be like, oh, now I remember the band name because you weren't thinking about it. So it's like Douglas Adams in Hitchhiker's Guide to the Galaxy. He explained that if you want to, he explained how you learn to fly. You learn to fly by tripping and falling down, but forgetting to fall, basically. So it's kind of like that. When you try to remember something, you should be trying to not remember it in order to remember it, which drives some people crazy because it drives you crazy with, I know this, but I can't quite pull it up. This tip of the tongue sort of thing. And they explain this theory of how cortical columns interrelate and create concepts. Patch holography, which is interesting. And okay, that's the end of that one. Let's see what else we got. Okay, bad joke, but my bad typing ruined it. Okay. Anyway, like I say, link in the description. This is people who are intellectually curious, people who are really alive will love this resource, and nobody knows about it. Nobody's supporting it. I really hope that nobody pulls the funding. I guess it's supported, they say, by this Brain Corp, Productivity, Automated Intelligence Unleashed, automation and whatever. So that's kind of cool. So, okay, guys, that's all I got. My son says, keep these things short. I'm going to try to overcome my inability to just get on and talk about things without having Dave or Scott or Austin come and help me out. Anyway, okay. Goodbye, cruel world. I'm out.